Hi, this is the part two of Geo Statistical Analysis lecture series. And in this part, we will discuss the data exploration. In this part, we will discuss about the histogram, normal QQ plot, general QQ plot, Voronoi maps, trend analysis, semi-variogram, and covariance clouds. This part is important from the viewpoint of data understanding whatever data you have collected, whether your survey data or you have collected with the help of internet. So whatever data will be there, it will give you an insight, and this is very important before you go to any kind of interpolation. You must have the understanding of your data, the nature of your data distribution. So first we will discuss about the histogram, and this histogram is also known as the frequency polygon. And the frequency polygon is a graphical form of representation of the data, and it is used to depict the shape of the data and to depict the trend. So this is a very useful graphical representation of the data, which will help us to visualize our data. So this arc map is open here, and we have our data, and this data is here. The data type is point data here, and if you will see what type of data is here, the data is the vegetation change, land surface temperature change, nightlight data, population temperature, area, January rent. I have taken the varieties of data. Why? Because each data has a different nature in terms of its distribution and another statistical characteristics. So for data exploration, we can take the geostatistical analyst tool here. So let me repeat it again. Be sure that under customize extension part, your geostatistical analyst option is checked. So if it is not checked, then geostatistical analyst tool will not work here. This is checked. Okay. The second thing you should, because here it is highlighted, but in case if it is not highlighted, then it will be in the editing mode. So you can see if it is in editing mode, this geo statistical analyst tool, the exploration part will not work. You see it is unhighlighted now. So just be sure that it is in stop mode. So in the exploration geostatistical analyst tool here, explore data, then all these features are given here. The first one is the histogram. So histogram option, this is the histogram here. So the histogram, in another words, we can call it frequency distribution. And the frequency distribution is a bar graph that displays how often observed values fall within certain interval or class. You can specify the number of classes of equal width that are used in the histogram. Means here there are 10 classes. If you are interested for 5, you can make it 5, and if you want more, then you can make more. This is up to you. So the relative proportion of the data that falls in each class is represented by the height of each bar. Here this is the example, which is using 15 classes. We can minimize it to the 10 classes also. So first thing which we have to keep in our mind that under the histogram, this is the graphical representation. You have to understand this x and y. This part is showing the frequency, and this part is showing the data set values. So under the layer part here, this layer part is open. We can choose the layer part, and here we can choose the attribute. So what is this here? It is showing the vegetation change. Uh, this is the data which shows the enhanced vegetation index. If I will take another data like population data, you know, because the population in Tigray region is highly, we can call it, it is not normally distributed. This is what? This is the frequency. And maximum, why it is showing all? Why? Because the lower values are showing the KBLS. But if I take the higher population area, the frequency, higher population areas, then you can see the urban areas. You see here, this one is here. Probably this is Mefele, where no, this is here in this part, and because it is showing the population density of the population. Okay, so you have to keep in your mind that how these bars are distributed on this plane. And let's see another one, that is the temperature or rainfall. So rainfall is here. Okay, so this is the area where rainfall is at lower side, but if you want to see where rainfall is higher, you can see this one, because this rainfall data is for January. Okay, so during January, in which part of Tigray region rainfall is higher? This is the northeastern part. Okay, so it will give you an idea. This is the graphical representation. So this histogram section is giving us two parts. The first is this graphical representation, and the second one is this the statistics. And as we can see here, the graphical representation we can uh, change by giving our bars values or by changing the attribute here, and graphically we can see that how the data is distributed, the frequency of the data. This is the first one, graphics, and the second one is the summary of statistics. The summary of statistics also you can divide into two parts. The left hand side, it shows us the measures of location, and the right hand side, it shows the measures of spread, how data is spread. So in this part, that is the measures of location, there is a mean, count is there, total counts are 666, means total KBL is 666 KBL. So from the viewpoint of rain, January rain, minimum is 0, maximum is 94. If you will change another attribute like population, here density is given per square kilometer. The minimum is 2.3% per square kilometer and maximum is 928% per square kilometer. Means because this is the developed data, so this figures can be changed. And the mean is given here, and what type of mean is this? This is the arithmetic average of the data, and this provides a measure of center of the distribution. The another here it is given the median. Median value is correspondent to the cumulative proportion of 0.5. So if the data was arranged in increasing order, 50% of the value would be lie below the median and 50% values would lie above the median. So it also shows the distribution. Median shows the distribution. And if you will see the quartile, first quartile and third quartile, so the first and the third quartile correspond to the cumulative proportion of 0.25, and 0.75. And median, you can say, you can call it second quartile here. So if the data was arranged in increasing order, 25% of the value would lie in the first quartile and 25% values would lie above the third quartile. So the next is skewness and kurtosis. It shows us the measure of the spread. As we can see here, this is skewness, and the value shows the coefficient of skewness. And the coefficient of skewness is a measure of symmetry of a distribution. For symmetric distribution, the coefficient of the skewness is 0. So as you can see that this is far above the 0. So first thing, your data is not normally distributed. But if you will see the another data, like it may be the temperature data. So the temperature data, the skewness is very close to 0. So your data is giving some normal distribution impression here. So here we can see another data also. It will give us an understanding of the change in the skewness and change in the distribution of the data. So let's see here, if I see the change in the EVI, so data is skewness is in minus. So so if it is negative skewed data, what it shows? It shows that it has a long tail towards the small size, small values. So as you can see here, minus, 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 minus. So this is what vegetation change. So minus value shows, if I take here these values, you see, all these are the minus values. All these are the values which shows that vegetation has decreased in this part. But so skewness is minus 1. What does it indicate? That more values, more cabeles are towards minus side, means vegetation has decreased here. And which area the vegetation has increased more? Highest increase in the vegetation is this area. And in between, where it is means there is no large change, if you will select here, you can find that these are the cabeles where there is no much significant change in the vegetation. So one thing should be clear, that is for symmetrical distribution, the coefficient of skewness is 0. If a distribution has a long right tail of large values, in case of maybe the temperature, yeah, then is or we can take another data here, like maybe, yeah, it's long tail towards the right hand side. Okay, so if the values are larger, then it is, if long is tail is towards right side, then it will be skewed coefficient will be positive. And if it has a long tail of small values, it is negatively skewed. So where the mean is larger than the median, for positive skewed distribution, mean will be larger than median. So in this case, mean is 7.1 and median is 5. So if your data is positively skewed, your mean will be larger than the median, and it is just opposite. If your skewness coefficient is in negative, then your median value will be larger than the mean. So this was about means skewness. And the next, kurtosis. Kurtosis is also a good indicator to give us an idea of the distribution of the data. So here kurtosis and skewness are very much interrelated. To explain kurtosis and skewness, let me take the help of the paint, and if I draw a line here and here, and you can see here, if this is a normal distribution, so the both the tails will be uh, equal here, and you can see this is the symmetrical distribution, and skewness will be here, coefficient of skewness will be 0. But if it is skewed towards right side like this, the skewness will be positive. And if your more data is given towards left hand side, if it is skewed like this, so here the skewness coefficient will be negative. So tail information is being given by the coefficient of skewness, and this peak information is given by the kurtosis here. So if this is a normal distribution, the kurtosis will be 3, and if it is above 3, then your more data is concentrated here in the mean side, and the shape will be like this, like this, if it is above 3. And if it is lower 3, kurtosis is low 3, lower than 3, then your more data is towards left and right side, and in the mean side the data is less here. So we can see here, if your data is more in the mid, kurtosis will be more than 6.32. And let's take another data like temperature data. Yeah, it is also means data is more here towards the mean side. Let's take another one, population data. You can see here the kurtosis 99, means more data is, there is a high peak in the and the tail is very thin. Let's take EVI data. This is 6. So all this data is showing that the peak is more because kurtosis is above 3. Yeah, in this case, temperature, the kurtosis is lower than 3, means the more data is concentrated towards the tail side. So this is how skewness and kurtosis will help us to understand the distribution of the data. So you can change the bars, and you can see the outliers in the minimum side and maximum side, and you can have more idea of your data. Like if I do it 20, and this is the temperature here, and if I want to know the lower side of the temperature, I think, yeah, lower side of the temperature here, means I think this is the change in the temperature. If I take another data like population, and okay, let's take the area data here. So there are some capillaries where the area is more, for instance this one. So you can see here this capillary where area is more, you can see in the polygon shape also. So the area of this capillary is the highest, very high, very high. So this was all about The histogram, you can see this video, you can use the data is also the data will be also attached to your PPTs. And now we will talk about the normal QQ plot and the journal QQ plot. So again we will go to Geo Statistical Analyst, explore data. For normal QQ plot, you will click here, normal QQ plot, and you will find again the data is only one. Attribute option is given here, that is only one. You cannot take two data. So but here these two planes, the this is, you can understand here, this is standard normal values plane, and this upper one, this one is for the data, actual data which we have. So here this is enhanced vegetation index. So EVI change, minus value shows the negative and positive shows the increment in the vegetation, and this part shows the standard values. So how this normal QQ plot is constructed, what they do: first the data values are ordered and cumulative distribution values are calculated here. Okay, so a cumulative distribution graph is produced by the plotting the ordered data versus the cumulative distribution. As you can see here, from lower values to higher values, this is the cumulative order, and this is for the standard normal values which are shown here, and this line shows the standard line. So if what is the much importance of this data is that there are some values which are very abnormal from the normal line in the lower side. Means if you are interested which area, which cavillages where vegetation change is in negative and highly means very abnormally lot of change in negative side, then you can select this data and you can find that okay, this is the area where from 2001 to 2010 there was a change in the vegetation, the negative change. Here you can see by giving the labels also. Okay, I have to choose the label option here. You see there is a lot of change, the highest change area, but at the same time you will be interested to know that which are the cavillages where during the same period, means 2001 to 2010, the change was positive, vegetation was increased, then you can select this area. Okay, these are the cavillages where vegetation was increased. So there is only one data which you can compare with the normal distribution. Okay, these are the cavillages here where from 2001 to 2010 the vegetation was increased here. So with the help of this tool, you can identify the problem, and you can identify that where is the problem, in which cavale there is a, for instance, this cavale here. Yeah, what was the reason why in this cavale vegetation is as much decreased, highest decrease in this cavale, and this is the change from 2000 to 2005 to, means mean of 2005 to the mean of 2005 and 10. So this is about the normal QQ plot. We can see the, if, okay, now we will move on to journal QQ plot. You can see here explore data and journal QQ plot. So one thing is, in both X and Y axis, in normal QQ plot, one axis was normal distribution and another axis was your data values. And in general QQ plot, it gives us the option to compare two data sets. So whether two data sets are identical or not. So one X will be showing one data set, another Y will be showing another data set. Okay. What we need is the first data set. Here it is shape, but let's see, the one data is temperature and another data I am also taking from point, another data may be temperature with EVI something, or temperature and, okay, yeah, EVI here. Okay. So if both the data are equal, then the line will be absolute 45 degree here, 45 degree. And if there is a change in both the data, then this line will deviate here. So we can take EVI, we can see EVI and temperature. So these are the two data sets. This data set is showing us probably the temperature, and here this is showing, because this is data set 2, here you can see, and the the factor is given here also, 10 to the power minus 1, here 10 to the power minus 2. Okay, so this data set 2 that is showing the temperature here, and this is showing the EVI. So as per the scaling factor, you have to understand your data. So if you want to know which are the areas where vegetation has decreased and the temperature is low, here, so you can find that these are the areas where temperature is low and vegetation has also decreased. So there is a relation in between, and this relation you can understand that the vegetation is decreased in the areas where temperature is down, lower side something. And on the other hand, you can see that this is the area where temperature is up, and the vegetation has also increased. So these are the areas. So both the graphs are very useful to explore the data and we can find the problem regions or hotspot regions by exploring the data like this. Now we'll talk about the Voronoi maps, and these Voronoi maps are very helpful to study the local variation. Suppose if you have one cavale, then around that cavale, what are the neighbors, and means you can smooth the values. So one is global, means the whole cavale you are studying, whole region you are studying. But if you are studying at a regional level or sub-regional level, then you can use the Voronoi maps for local studies. So to create the Voronoi maps, we have to go to Geo Statistical Analyst, explore data, and Voronoi maps, and we can give the data. Here I'm giving the population data, and as you can see, with the help of this interface, we can clip also to the shape. Okay, now your data is clipped to the shape here. So one thing is here, that is Voronoi maps are constructing from a series of polygons formed around the location of a sample point. These polygons have been created around the sample point. And why these are created? These are created so that every location within a polygon is closer to the sample point in that polygon than any other sample point. In other words, we can say that if there is a polygon, then the nearest distance is that point only. And as you can see here, the basic objective of the Voronoi map is to examine the local variation. And here we can change the attribute data, like this is the nightlight data this time. And here the values are classified into 5 categories. We can make it population also. The legend will be changed. So with the help of Voronoi map, we can identify the local variations. So here the important thing is the neighbors. We can study the neighbors, and using this definition of neighbors, a variety of local statistics can be computed. And this local statistics may be mean. As you can see here, the type, you can change the type. This is a simple, and in the simple the values of the points are taken. But if you will take the mean, the values assigned to a polygon is a mean value that is calculated from the polygon and its neighbor. Suppose here the value is 100, and in another polygons the values are less, maybe 2, 3, 4. So the new value which will be assigned to this polygon will be the mean of all polygons, like 1, 2, 3, 4, 5, 6, 7. So these 7 values will be sum divided by the 7. Then the mean value will be assigned to this polygon. The good thing is that we can export this data, and that data we can use in our research. Wherever you want, you can, like this is Voronoi map, VM, okay, save it, and you can import it. So this Voronoi data will have like the each polygon will give you the mean, mode, cluster, entropy, median, standard deviation, like this. So it's a very good tool to study the local variation. Similarly, you can change, yeah, here it is. All this is just for understanding. You can see that these are the polygons created here, and the actual polygons of the cabeles you can see here, and these polygons may or may not be overlap. And as you can see, any area, suppose okay, just to explain this one, like this is a cabele name is my Anbesa. So some part of this nearer cabele means the western part of this cabele, eastern part of this cabele, mi INA, my INA. From western part, if anyone want to go to the centers of the, so means the nearest distance will be to this area here instead of going to uh, this center. So this tool is also useful to study the local variation in. So there are some significance if you are using like mean, mode, median. So it will give you a local smoothing of the data, and the higher and lower values will be averaged and your data will be smoothing. If you are interested for local variation, to understand the local variation, you can use the standard deviation, you can use the interquartile range, you can choose the entropy. If you want to see the local outliers, you can use the clusters. When you will take the clusters here, clusters, then all your data will be classified into 5 part in the cluster, but there will be extra, that is the sixth one, and sixth category will be shown in the gray color here. This is the sixth category. So what this sixth category will indicate will be the difference from its neighbor, means there will be a large difference. Suppose here if this is okay, let's see, suppose here this one, okay, so the population of this polygon is very much different from the another polygon. So it will help us, the sixth class will help us to distinguish it from its neighbors. And this was about the clusters. And now we will talk about the trend analysis. And trend analysis is very important when you are interested in mapping a trend, that how values are increasing or decreasing from north to south and east to west. And or maybe if you aren't doing grading, then you might want to remove a trend from the data set because when you are doing kriging, you are using kriging, there should not be any trend in your data. So it is important to know that the data is having a trend or not. If it is having a trend, then it will be helpful to take means to make it detrend. So to study the trend analysis, we will go to the explore data. Then this is trend analysis here, and the trend analysis tool, it provides a three-dimensional perspective of the data. Here you can see three-dimensional perspective: x, y, and another is the z. So z is the value, and xy is your longitude and latitude. So as you can see here, it looks something very confusing, but you can suppose here this is the grid, so you can remove the like sticks are here. If you will click, sticks will be appear. If you do not, then okay, if you need sticks, you will get it, otherwise no need. And here this is the projected data, and here this is the trends. These are the trends. Okay, so one thing is here, this is the attribute which you can change, like okay, we can see this one here. This plane will show you the latitude. Okay, here this one, the blue part, blue line. On the other hand, green line you can change to another color also. It is showing you the longitude. So with the help of these lines, you can understand. If I take another value, it will like maybe the temperature. Okay, yeah, we can see here this plan, the graph is moving down. What does it mean? It is highly interactive also. If you will see these values, you will find here. So here these are the higher values, means temperature is higher here. So what is we can understand that as we are moving from west to east, the temperature is decreasing here. So this is the trend, clearly visible trend. Again, we can come here, we can see this one, we can see these values. As we will move from west to east, temperature is decreasing. And longitude we can see, latitude we can see here, these are the values. Temperature is down, but as you will move from south towards north, the temperature is increasing, and this part the temperature is increased here. This is the part which shows the from the viewpoint of latitude, the temperature is increased here, but again it is decreasing here. Here this part is decreasing because here elevation is more. So this tool is also very useful to study the trend in the data, and we can rotate also by location for our better visualization. Here we can rotate it, and yeah, and we can rotate it by graph also, like this. Another data, like if we want to know the enhanced vegetation index, change in the vegetation, so these values are showing that here the EVI is down, means the vegetation has been decreased, but as we are moving from the latitude to up, from south to north, the vegetation getting better condition here. So this was about trend analysis. If you want, if you are doing some work, you can add to the layout, so this trend will be showing in your map also. So finally here we will talk about the semiovariogram, and this tool we can use to examine the local characteristics of the spatial autocorrelation within a data set, and this will help us to analyze the local outliers. So spatial autocorrelation means here the space will be involved, the distance will be involved. So for semi-variogram, we will go to the tool here, explore data, then semi-variogram. Okay, and thereafter we have to we will see the data something like this, and as we can see the x-axis here distance is given, and the y-axis the values are given, values of semi-variogram. So here attribute we can change whatever we want. Here maybe temperature. So this tool can help us. So each point here uh, it represents a pair of points in the data set. Suppose if I will select one point here, then this point will represent a pair here. If we are, if this is the distance scale, if I will take the nearer one, then all these points which distances are less in between the points will be selected, and if I am taking here, the long distance points will be selected. And again, one thing which I am interested to know, which are the areas at close distance and the semi-variogram value are also less here. So all these are the points where the difference is very less in the values. So here this is the data which is showing the temperature. We can take the data and we can see. Here we can label it. We can see the data is very close, like 21 21, 22 22. So there is a least variation here. And if you want to know that even distance is more but the variation is less, which are the areas? You can see those areas. The distance is more but variation is less here. As we can see, this 27 and this is 31. But in some if we are interested to see the same distance, then we can take one specific. Okay, the large amount of data has been selected because it takes more data to make the semiogram clouds here. So what are these values and how these values are generated? For this, suppose if I am taking this value here, this one. So this value is given here as 1.09. And what is how these values are generated? This is the difference of these two values. One is 19.41 and another is 19.41 and another is 34.25. 34.25. So first what they do, they take the difference in between these two and thereafter they make a square and thereafter they divide it by 2 because this is semi-variogram. So semi means they are dividing by 2. So this is around 110 and here this is close to 110. So that you can rescale by this value using this value. So this is 110. So this is the way all these values are showing us the semi-variogram. And this semi-variogram is very useful to understand during the last exercise when we will learn the kriging. Because in the kriging, this calculation and the use of this one is very important. There are another functions like here there is no direction is given. Suppose if you want to search the semi-variogram in a particular direction, then you can choose the direction. Suppose here, okay, you can change the angle and you can change the lags also. If you will close it, your lag will be decreased, that is 1.9. And this time all the values are showing north in the north south direction. Suppose if I will choose this one here, these values will show you north south direction. So if you will minimize this lag, then it will be more north to south. Here you can see this one, more north to south. And if you are changing the angle, if your interest is to search the variation more east to west, then you can see here it will be east to west searching, and you can see that how distance is increasing and how values are uh, changing. So higher difference with higher distance, you can select this one. Higher distance, lower variation, you can choose this one. Lower distance and values are similar, you can choose this one. Lower distance, higher change, you can see this one. More differences here. The temperature is 18, here 34. So we can study semi-variogram like this. This is the lag, this is the bandwidth here, this is angle tolerance, angle direction, which you can change according to your need, and you can see the results. So this was all about the data exploration. In the next exercise video, we will talk about the interpolation and the third video will be like the deterministic methods, how we can make the surface using the point data using the deterministic method. And the last fourth video will talk about the geostatistical methods. So this was all about the exploring the data, because I collected different types of data. That's why it took me 2 days to prepare this video. The next video I will prepare soon and I will share with you. Thank you very much.